Hi guys, welcome back. Let's briefly look into Slaters rule. Slaters rule strictly is not in NEET syllabus, but it is in JEE syllabus. It's not in CBSE book per se. Still, I want you guys to learn it for two reasons. One is, if in case it comes in NEET, I want you guys to be able to get those 4 marks. Second reason is, it's also not a lot of work. It's actually very, very simple. So let's just make sure that we don't miss this question if it comes. Basically, what Slaters rule is doing is, it's quantifying the shielding effect experienced by the atomic electrons. So for example, you have your nucleus and you have your inner shell and outer shell. Take an outer shell electron. Okay, this is the outer shell electron I have. Why is it in the orbit and not going away? Because of the nuclear pull, attraction of the proton and the electrons. Okay, the nuclear pull is pulling it inside. At the same time, it doesn't fall close to the nucleus because the inner core electrons repel each other. Slaters rule actually is going to predict what is the repulsion and what is the net effect that the Z is going to pull the outer electrons. So basically, it is going to be whatever this attraction minus repulsion should be your Z effective. But we are going to quantify it, meaning actual numbers. To get to Slaters rule, first couple of things we want to do. We want to be able to write the electronic configuration of an atom. We have done this so many times for pretty much most of the atoms in the periodic table. And you want to write them in the order of Aufbau principle. It doesn't really matter Aufbau principle here, but it is easier if you do Aufbau principle, and we have learned that also, N plus L rule. Now, we need to identify the electron of interest. What it means is, ஒரு given elementல outermost electron அவங்க கேட்கணும்ன்ற அவசியமே இல்லை. It could be any electron. For example, the given one could have a 5p electron, but I can ask you what is the Z effective or the shielding in a 4f electron or 4d electron. So you need to know the electron of interest and ignore all the electrons in the higher energy to the right. For example, நான் வந்து 3d electron கேட்குறேன்னா இது எல்லாமே நீங்கள் ignore பண்ணிடலாம். If I am talking about this electron, it is being shielded by electrons inside if it were any and electrons in the same orbit, but it is not shielded by anything outside. There goes the name shielding, right? Okay. Now, how does it work? You want to remember these numbers. There are two types. கேட்டிருக்கிறது S or P இல்ல D or F நீங்கள் தெரிஞ்சுக்கணும் முதல்ல. அவங்க கேட்டிருக்க electron of interest. S or P ன்னு கேட்டாங்க அப்படின்னா, what you want to do is you want to remember these electrons within the same orbit. So, now 3p கேட்குறேன் அப்படின்னா, or let's say, 3p. Electrons within the same orbital shield 0.35. So, 3p கேட்டால் 3s உம் 3pல இருக்கிற மிச்ச எலக்ட்ரானும் நம்ம பார்க்கலாம். It will be 0.35. Except 1s which is shielded by 0.30. Okay, what it means is, now 1sல இருக்கிற electron, helium நான் கேட்குறேன் அப்படின்னா, heliumல 2 electron இருக்கும். ஒரு electron is shielded by the other electron. The contribution of shielding by the other electron is only 0.30. 1s na. Suppose I ask 2s. I take beryllium. Berylliumல 2s2 இருக்கு. அப்போ ஒரு 2s இன்னொரு 2s எவ்வளோ ஷீல்ட் பண்ணுதுன்னா 0.35 not 0.30. But 1s is not always 0.3 in other cases. Electron with n-1 orbital shield 0.85. We are going to see examples, don't worry. In the numbers மட்டும் நீங்க ஞாபகம் வச்சுக்கணும். n-1 orbital general, they don't say what type of electrons. Every n-1 is 0.85. Anything below or innermost n-2 or lower is going to shield 1. So as you can see here, இதுவும் 1, இதுவும் 1. கேட்டிருக்கிறது ND or NF electron அப்படின்னா, electrons within the same group shield 0.35. No difference here and here. n-1, n-2க்கு difference இல்லை. எல்லாமே 1. It is actually easier when you do d electrons. Now if you see here, n-1, n-2, n-3 கொடுத்திருக்கேன். S and Pக்கு 2 different values இருக்குங்க. And then 1 for all inside. Whereas D and F electron, only 0.35 is same as 0.35 over here, but there is no 0.85. You want to remember that. That is going to play a huge role later. Let's see, this is actually a tabulated value of what I have been teaching. And the diagram la irukradha na tabulate பண்ணிருக்கேன். What are we going to do is, to calculate the net shielding experienced by an electron, we are going to sum together the contribution of all these type of electrons. That's all. Now this is what? Say, summation of the number of electrons in a specified shell and subshell. Okay, shell na n minus 1 and the corresponding shielding electron values. Obviously this is much rather easier if we do an example. Let's take an example of nitrogen, and here the electron of interest is a 2p electron. I have written down the electron configuration of nitrogen. Because I'm asking 2p, which is the outermost electron, there is nothing to the right, so I don't have to worry about them. Now when I take 2p, if I have 2p, then let's do stepwise. N is 2, n minus 1 is 1. Okay, in the same group, I'm talking about this one, so 0.35. So there are 5 electrons. ஒரு எலக்ட்ரானை பற்றி நம்ம பேசுகிறோன்னா அந்த ஒரு எலக்ட்ரானை 4 எலக்ட்ரான் தான் ஷீல்ட் பண்ணும். ஸோ 4 times 0.35, what is inside is shielded by 0.85. So inside there are 2 electrons, so that is your shielding. Very simple. That is pretty much it. Shielding calculate பண்ணுறது, it is not hard at all. Let's see another example. What is the shielding constant experienced by 3D electron in bromine? So here I was careful enough to bring something different. I'm talking about 3D electron. So this electron. What is the inner core? Idellame inner core. What is the outer core? This is outer core. This is outer core. So I do not take it into account. Fair enough. Okay, now that we know this, let's look into it. It's a d electron. So d electron வந்து டிஃப்ரெண்ட்டாக பார்க்கணும் நம்ம. இங்கே ரெண்டுமே n மாதிரி இருக்கும், but this is a different orbital altogether in terms of energy, right? So there are 10 electrons. I take the 9 over here. d electron பார்க்கும்போது d தனியாக நீங்கள் பார்க்க போகிறீங்க. 9 electron, மற்ற எல்லாமே core electron. All the core electron contribute to 1. So there is 6, 7, 8, 8 plus 6, 14, 15, 16, 17, 18. So இது வந்து n minus 1 மாதிரி தெரியும், but d electron பார்க்கும்போது இது எல்லாமே நீங்கள் ஒன்றா பார்க்க போகிறீங்க. Okay, so 18 times 1 and 9 times 0.35, 21.15 is what you're going to get as an answer. Now I'm going to actually use a really good example, what Slater actually published. What is the shielding constant experienced by different electrons in iron? So there are so many different types of electrons. 4s இருக்கு, 3d இருக்கு, 3p, 3s இருக்கு, 2p or 1s, however you want. Now this is a really good example. Now 4s is outermost, separate. Now இது எல்லாமே n value ஒன்றா இருந்தாலும் இதை தனியாக பார்க்க சொன்னேன். See, they are seeing it differently. And then 2p and 2s are same, 1s is same. Now if you see, go back to the table, you will see that 4sக்கு நம்ம பார்க்கும்போது there is nothing to the right that I have to ignore. Inside when I go, I have s equals. S is not s orbital electron, shielding constant சிக்மானும் யூஸ் பண்ணுவாங்க. ஒரு s இருக்குது ஏற்கனவே, அதில் 2 எலக்ட்ரான், அதில் ஒன்று கால்குலேட் பண்ணுறோன்னா இன்னொன்று ஷீல்ட் பண்ணுது. ஸோ 0.35 times 1. எஸ்ஸை கால்குலேட் பண்ணும்போது இது எல்லாமே n minus 1. n minus 1 for s orbital is 0.85. Then all this becomes 1. Now when I go to D, obviously what we need to do, I don't have to worry about this. ஏன்னா இது outermost மாறிடும் to the right. 6 electrons இருக்கு, அப்போ 5 ஷீல்ட் பண்ணும். ஸோ ஐ ஹாவ் திஸ். எவ்ரிதிங் எல்ஸ் இஸ் கன்சிடர்ட் ஜஸ்ட் லைக் ஆர் கேஸ் ரைட் ஹியர். நம்பர் வந்து இது ரெண்டும் n மாதிரி இருக்கும், பட் நாட் ஃபார் ஸ்லேட்டர்ஸ் ரூல், அண்டர்ஸ்டாண்ட். அக்கார்டிங்லி யூ கேன் கால்குலேட். 3s 3p பார்க்கும்போது I can ignore all this. There are 6 plus 2, 8 electrons, so 7 of them will shield. And then இது n. இது n minus 1. n minus 1 is 0.85, 8 electrons. n minus 2 is 2 electrons. 2s 2p பார்க்கும்போது it's much rather simple. So this is a really good example of a same atom, different electrons, how are they shielding? So now say which is shielded the most. Now this is the thing that you want to know. ஒரு எலக்ட்ரானை நல்லா ஷீல்டு பண்ணிட்டோம் அப்படின்னா நியூக்ளியர் புல்லுலேருந்து அதை ஷீல்ட் பண்ணிட்டோன்னு அர்த்தம். So if you are shielding an electron very well, meaning it is not experiencing a lot of pull from the nucleus, so it can be taken away easily. So if I were to take away easily, அப்போ shielding அதிகமாக இருக்கணும். So what is the highest in shielding? This one. So it is easily taken away. Now what is taken away easily after that? 3D, 3P, 3S, 2S, 2P, and then 1P. Now this is the actual order of ionization, not ionization energy, actual order of ionization. In the order la ionize agum, first idu adutha idhu agum, ionization energy idhukku opposite ah irukum. So you can say ionization energy is the amount of energy you have to put to remove an electron. Ionization energy will be inversely proportional to shielding. Shielding அதிகமா இருந்ததுன்னா உங்களுக்கு ஈஸியா அயனைஸ் ஆகும். Now we can actually relate it further using Z effective. Now where is shielding useful? In the S க்கும் இன்னொரு symbol வந்து sigma. Depending on the book it can be changed. S or sigma. Z effective we have already seen, the effective nuclear charge. This is a quantitative measure. Z is the number of protons. Okay, this Z is the number of protons for any given element. Iron கொடுத்தாங்கன்னா அதோட number of proton உங்களுக்கு தெரிஞ்சதுன்னா minus இந்த electronic shielding நம்ம calculate பண்ணலாம். This S value we already saw in the previous slide. Now we are going to calculate Z effective. This is the number of proton. Ironக்கு எல்லாமே 26 proton, doesn't matter where you are talking about. எந்த electron பார்த்தாலும் proton மாறாது. Now Z effective. Now if you see, Z effective is inversely proportional to S. ஏன்னா நீங்க S அதிகமாக Z effective கம்மியாகும். So we saw the shielding is high for 4S, meaning poorly protected, it can be easily ionized. Or we can say Z effective is lower. We can say ionization energy is proportional to Z effective, inversely proportional to S. Now we are going to see what are the various things that Slaters rule helps us understand. Okay, there are three important things that you want to know. The theory question varalam. Basically you don't have to calculate this, you can get the idea. 4S, so you can remember this, 4S in terms of shielding is shielded more than 3D, and in terms of your Z effective, 4S less than 3D. This principle you want to remember. Now let's see where all it is useful. Why is 4s orbital filled earlier than 3d orbital? Okay, 4s is filled earlier than 3d orbital. We already know that. நம்ம d block fill பண்ணும்போதே 4s 2 க்கு போட்டதுக்கு அப்புறம் 3d1 3d2 ன்னு போவோம். Now obviously our first explanation is Aufbau principle, n plus l rule. We know n plus l போடும்போது 4s க்கும் 3d க்கும் என்ன வரும்னு தெரியும் நமக்கு. But can Slaters rule explain it as well? Let's look at the two configurations. These are the two configurations possible. 3s2 3p6 வரைக்கும் okay. The last electron for potassium can enter 4s1 or 3d1. We know this is the case. But why don't we put it in a n orbital, n plus 1 orbital? Why do we put it? Aufbau principle says, but let's see what the Slaters rule can do. Previous calculations, Z effective நீங்க calculate பண்ணலாம். 4s னு போட்டா 4s க்கு nuclear pull என்ன இருக்கும்னு. So this is n orbital. There is no other n orbital, so 0 times 0.35, 0.85 times 8 electrons, and 6, 7, 8, 9, 10 means 10 times 1, and then we can do 19 minus the corresponding number, 2.20. Now look at it, if it were this case, 3d1 nu pota enna agum paakalam. If you calculate it, this is what we get. So Z effective for this is much higher than Z effective for this. So obviously இந்த nuclear pull அதிகமா இருக்கனால nuclear pull வந்து attraction exothermic மாதிரி பார்க்கலாம். So attraction is higher in this. So this is another way of explaining why 4s is filled before or 3D. Now again இதை நீங்க calculation மாதிரி உங்களுக்கு வராது. You just want to be able to explain it. Alright, this is basically explaining what I just said. The second important thing you can understand from Slaters rule is when transition metals are converted to cations, right here, manganese going to Mn+. It's the Ns electron, not the N-1d element. So, போடும்போது first நம்ம வந்து 4s போட்டுட்டு அப்புறம் 3d போட்டோம். எடுக்கும்போது reverse எடுக்கிறோம். Can Slaters rule explain it? Let's look at it this way. This is manganese. ஒரு electron எடுக்கணும். What electron we can take? We can either take this electron or this electron. The order of filling is இதை fill பண்ணிட்டா இதை fill பண்ணோம். அப்போ இதை முதல்ல எடுத்தா I will end up with B configuration. As we know, we already take this one. Based on class theory, we know that this is A. Now let's explain why A and not B. For option A configuration, sorry, this is option B. Option A configuration, 4s electron is removed. 4s2 ல 4s1 மாறி இருக்கு. Option B configuration, 3 electron is removed. 3d5 ல 3d4 மாறி இருக்கு. Once you look into the Z effective of 4s and 3d, you will see the Z effective of 4s is 3.6, Z effective of 3d is 5.6. So obviously 3d உங்களால எடுக்க முடியாதுன்னா Z effective அதிகமா இருக்கு. You can calculate yourself and see. Z effective அதிகமா இருந்தா obviously nuclear pull is high, so I take the 4s before I take the 3d. This is another important point to note based on our Slaters rule. And the last one, variation IE values, IE1, IE2, IE3, we saw this in periodicity. The successive ionization energies are always higher. Now you can say based on this calculation. Now going back to the table, NS ல இருக்கிறதுக்கு வந்து 0.35 வேல்யூ கொடுத்தோம். IE1 ஓட IE2 ல NS ல ஒன்று கம்மியாக இருக்கும், IE3 ல இன்னொன்று கம்மியாக இருக்கும். Maybe it is easier if I just do it. Let's say for example, our nitrogen 1s2, 2s2, 2p3. So Slaters rule use பண்ணலாம். I'm going to have 1s2, 2s2, 2p1, 1s2, 2s2, sorry 2p2, 2p1. Now if I were to calculate the Z effective for this p orbital electron, இது எல்லாமே constant எல்லாத்துலேயுமே. So I don't have to worry. I'm just doing it very fast. இதை நம்ம calculate பண்ணலாம் வேணாம், எல்லாமே ஒரே மாதிரி தான் இருக்கும். Look at it this way. The contribution 0.35 times there are 5 electrons, so 4. 0.35 times 3, 0.35 times 2. அப்போ ஷீல்டிங் கம்மியாயிட்டே போகுது. ஷீல்டிங் கம்மியாகுது அப்படின்னா Z effective அதிகமாகுது. So Z effective increases, so I cannot remove an electron easily from N2 plus compared to N plus. Similarly, I cannot remove from N plus easily compared to N. So you can relate it to ionization energy. These are the details you need to know regarding Slaters rule. This is more than enough. Practice it couple of times. This is something that you want to remember crudely. Okay, and the values mattum exam ku munadi already paathukonga, final exam munadi. Otherwise you don't want to be solving all of this. It's not that important for you guys. Nevertheless, let's know this in case it comes in our year of NEET exam. Right? Thank you guys.